Okay, so yesterday we were doing some stuff with functions, but we were kind of doing it when it was like a graph and then figuring out domain and range from the graph. We're going to kind of keep going with that today. So the first thing we're going to do there is we're going to attack that activity on page 35. So you'll need your calculator. And the first thing it says there, suppose a puddle of water is evaporating and its depth, d of t, in inches after t days is given as the formula d of t is equal to 6 minus 16, or 1/16 t squared. What does evaporating mean? Like what happens when water evaporates? Yeah, I don't need a scientific answer. It goes away, right? So it's going to make the puddle less full, right? So our volume or our depth in inches of that pool is going to continue to go down, right? Okay, so evaporating means it goes away. The values are going to go down. Okay, so what it wants us to do is it wants us to enter that equation into our calculator. So we're just going to go y equals. If you've got anything in there, just clear it out. And then again, like we talked about before, that d of t doesn't really mean anything different than the y, so you're just going to put it in just as the y.
Attention, we need 7th graders who are in Mr. BK's advisory, 7th graders in Mrs. Frost's advisory, and Miss Fortin's advisory. Please report to the cafeteria to get your pictures taken. 7th graders in Mr. BK's, Mr. Boston Kempel's advisory, Ms. Fortin's advisory, and Mrs. Frost's advisory. Try to line yourselves up alphabetically in order by last name in your advisory line.
Okay, so the little formula is 6 minus, and then I always put my fractions in parentheses, so 1 divided by 16, and then x to the power of 2. Okay, and then once you get that typed in, what we're going to do is we're going to look at the table. So to look at the table, you would go second, and then graph button for table, so second graph button, and it kind of gives you the table out. What we're actually going to do is we're going to take this table and we're going to manipulate it to kind of start at a place that we actually want it to start at, and we can also change what it's counting by if we want to. So what it says for our next step there is set up a table to start at -5 and generate values in increments of 1. Okay, and if your ever needs an end value, we use 5, but I don't think we do. So to change how this table looks, you're going to go to something called table set. So it's above the window there in blue. So if it's in blue, that means we hit our second button. And then you're going to hit that window button because that's the table set. And that just gives you like a setup for your table. You can change it however you want. So the first thing there is table start. So that's where like the table's going to start, the first number in the list. They want us to change that to -5. And then the next thing there, this little triangle and then table, the little triangle means change, so it's telling you how much each one's changing by. We want to set it at 1, so just make sure that next one there's a 1. I think the default's a 1 as well, so it might be 1 already. So -5 and 1 is those. And then the other two things, you don't really need to do anything for those. So then now if we go back to our table, so second table, now it should have jumped to starting at -5. And then each of those is going up by 1 on the x value. Does that kind of make sense? And your little table there should look like there's an example in the book. Right there. You should have the same exact numbers as what it has in the book. Everybody have the same exact thing as what's in the book? Okay. Alright, so that's that. So if they ever ask you to mess with the table, that's how you do that. So then we can skip down to step 4. Values in the x column represent which variable in the problem. Okay, so looking back to our formula there, we had d of t is equal to 6 minus 1/16 t squared. Looking at the numbers in our list here, what does the x represent? It would be the t, right? So the x would be like our time values here. I think it's in days. Yeah, t days. But yeah, the x would stand for the t, so then what's the y stand for? Well, so it'd be d of t, but yeah, yep. So that the depth of our thing, which is the d of t, yep. And then the next question says, do all ordered pairs in the table realistically model the puddle in the situation? Why or why not? So if we think about this here, looking at our x values, are there any of those values from our table that wouldn't make sense to us? If we're thinking about time, are we having -5 days for time? Probably not, right? So really those negative values aren't going to be of value to us. So really just the positives are, and if you need to get to the positives, if you scroll, you can use your up and down arrow keys to keep scrolling too. Okay, so then it says for step 5, determine the water's depth after 6 days. Okay, well 6 days, what was our days? The x or the y? The x, so we just go up to 6. 6 tells us our depth would be 3.75 after 6 days. And then the next one, so that would be, if you wanted to write it, it would be d of 6 for the t is equal to 3.75. And then the next one, when is the water depth 5.75 inches? So that would be kind of working that backwards there. Okay, so if we're doing that, what do we think for that one? It would be the 2 days, right? Because we're going backwards with it. They're giving us the depth, so we go backwards and it would be 2. Kind of follow on that a little bit? Okay, so that's if you ever have to use the table function there. Okay, so next thing here, so a function doesn't need to be defined as a formula, so it doesn't have to be something like this to be able to come up with a table. Sometimes they're just going to give you a list of ordered pairs, and that could still be a function, okay? And then it says tables give discrete views of functions and show only some ordered pairs, and then graphs give continuous curve that shows all values in the domain and range. Do you guys remember what discrete geometry was from last year, what that looked like? So discrete means when it's just like individual dots like that, okay? Continuous means like it's like some sort of like curve with like no stops in between, okay? So if they say something about discrete, it's just like discrete geometry where it's just a bunch of points. Continuous is, you know, there's no stops in between. So if it was written as discrete, you're just seeing those ordered pairs. Continuous, your domain and range would be like the whole flow through that whole value. Does that make a little sense? Alright, next thing here. Okay, and reminder, all the examples should be in our example packets, right? Yeah, so don't worry about writing the examples because we'll just pull it out of our packets. Okay, so we got Robert Wadlow is the tallest person in medical history whose height has been sustained. At birth, he was of normal height. The table below gives his height h at various ages a, where f of a is equal to h. Okay, so we got his ages there across the top, heights there across the bottom, and the first thing they ask for is the domain of this. Okay, so domain looks a little bit different when it's just points. So like yesterday when we did our domain and range, it was over kind of like a path like that. That would be more continuous. And then we did our domain and range as like those inequalities, including all this stuff in between. When we do our domain and range here, it's not continuous. It's more of a discrete view. So we can only include the values that they give us there. Okay? Which letter represents the domain, X or Y? The X does. Okay? So looking at this information here, which of those values do you think is the X? The A would be the X value because it's always the one that's in our little parentheses there. So for our domain here, we just list it as the set of, so like with the little squiggly, and then you just list out those individual numbers that would be like, so this would be kind of like our X and that would be kind of like our Y. You just list those out. So it would be like 8, 10, 16, 18, 22.
Attention, all the rest of the 7th graders, please report to the cafeteria for your pictures. And if you are an 8th grader in Miss Cummings' advisory, please report to the cafeteria for your picture. Remaining 7th graders and Miss Cummings' 8th grade advisory to the cafeteria for pictures.
Yeah, so if it's in a table like that and they only give you those specific values, that's how you write your domain. Same with our range. So if that was our domain, what do you think our range is? All the bottom ones, right? Yeah, so it'd be still the set of, so the squiggly things just mean set of 1.9, 2.0, 2.4, 2.5, 2.7, and then we just end our set with the other curly Okay, and then for C, they want us to find f of 16 and what it represents. Okay, so again, whatever's in our parentheses is kind of like our x value, right? So if we're finding f of 16, what do you think that means for our height? The 2.4, right? So here, 16 goes with 2.4. So when we write this out, you could go f of 16 is equal to 2.4. And then what does that mean in terms of our problem here? Like in context of like the age and height. Yup, exactly. So at age 16, he is 2.4 meters tall. Yep, exactly. Okay, so now they give us one again where they want us to go backwards on that. So we've got f of a is equal to 2.7. So what do we think there? 22, right? Because if we look up here, now we're going, that would represent our y value. So 2.7 is there, 22 is there. So I would go, how should we do it here? Let's go f of 22 is equal to 2.7, or if you just put 22, I'd be fine with that too, because it doesn't actually say to put it in like the function notation stuff, so you can just leave it 22. Same with that other one, you could have just had the 2.4, either's fine. It doesn't ask this, but what does that one mean? Yeah, yup, so when he was 2.7 meters, he was 22 years old. And then in comparison to what that would be in like real life, 2.7 meters, you're like, oh, 2.7 doesn't seem like a lot, but 2.7 meters is actually 8 foot 11 inches tall. Can you imagine being 8 foot and 11 inches tall? That'd be shitty because most ceilings are 8 foot, right? Okay, anyways, so that's it. So book page for tomorrow, page 36, 1 to 17, and then tomorrow we'll move on to 1 to 6.